really understand what's going on. So the first one, we have this, that we need to find the integration of sine squared x times cos cube x dx. Now the good news is that, especially for sine and cos, if one of them or both has odd power, then that problem is a little bit easier problem comparing to other problems. If both of them has even power, or sine or cos alone and both of them has even power, then those type of problems are a little bit difficult. Okay, so what do we do when we really find that we need to find the integration involving sine and cos and one of them has odd power? Then what do you do? For this one, we split up that odd one and take one trig function out of that one. So what I'm trying to say is this, that sine square x, that's the even one, do nothing. But from cos cube x, I will take out 1 cos x and write it with dx. Just 1 cos x, that's it. Then we have to do something, we need to do a little bit, modify a little bit more, which is we do nothing on these last two terms, cos x and dx, that will be fixed forever. But the rest of the thing will be in sine. Okay, so in the rest of the part I can see there is a sine square x and cos square x. So we have to change this cos square x into sine. So this would be sine square x, and instead of cos square x, by using the trig identity, we can write that cos square x equal to 1 minus sine square x. Again, we do nothing with the last two terms. Okay, so we have used this trig identity, which is sine square x plus cos square x equal to 1. Okay. Oh, so now we are ready to substitute. What is the substitution in this case? It would be the sine. So u equal to sine x, then du equal to cos x dx. All right, so let's go there and replace all those variables. Sine square x, since sine x is equal to u, so sine square x will be u square. Then 1 minus sine square x, again that would be u square. And cos x dx will be replaced only by du. Now the next thing we need to do is to distribute. So if we distribute, that would be u square minus u to the power 4 du. Again, so far everything is going nice. Now let's find the integration. The first one would be u cube over 3, then u to the power 5 over 5. And since we are done with the integration, we need to add the c there. But we cannot stop, since this is not our final answer, because the answer is written in u and we are not allowed to leave our answer in u. We have to write our answer, the variable that we started with. So we can see that we started with, if you look at the problem, everything is in x. So our answer has to be also in x. So let's say, so u cube, we know that u equal to sine x, so we can write sine cube x divided by 3, and the next one we can write sine to the power 5x divided by 5 plus c. Just try to understand what's going on. When you understand what is the concept, then doing problem This kind of problem is very easy. All right, let's move to the next one, unless if you have any questions. Okay, so if we look at the next problem, that one we also can see it is also similar type of the first one because it has odd power. So we know that if we have an odd power, then we have one strategy to follow. That is this. What do? We take one trig function from that odd one. So since this is sine cube x, we will write as sine square x. Don't touch, oh sorry, that's not x, that's theta. And this would be cos to the power 4 theta. And one that sign that I just split up, that would be written at the end with d theta. And what is our plan? Again, we do not touch this last two, and the rest of the thing has to be in the opposite. That means it is a sine, so we have to use the cos one, right? So let u equal to cos theta. That one we will do. But before that one, what is our goal is that everything, the rest of the problem, beside that sine theta d theta, has to be written in cos theta. So this 1 minus sine squared theta needs to be replaced with the cos version. So which is 1 minus cos squared theta, and then this would be cos to the power 4 theta, and this is sine theta d theta. Now here du equal to negative sine theta d theta. Okay, so if I use this one, that would be 1 minus cos theta. Cos theta is u, so 1 cos squared theta will be u squared, 1 minus u squared. Cos to the power 4, that would be u to the power 4. And sine theta d theta will be negative du. Okay, so let's multiply that all out, distribute. So that would be u to the power 4 minus and plus u to the power, sorry, I want to switch the position, so that would be u to the power 6 minus u to the power 4 du to get rid of the negative sign. Okay. Now the integration of this one would be u7 divided by 7 and u5 divided by 5. Since we are done with the integration, let's see. Now again, we cannot leave it as it is. We have to plug the value. So u equal to cos theta, so that would be cos to the power 7 theta divided by 7. And that would be cos to the power 5 theta divided by 5 plus c. Any questions? Perfect. So the next one is this one, where you have sine to the power 7 theta and cos to the power 5 theta d theta. That means we were looking for an odd power to either sine or cos, but in this case both of them share the odd power. Since both of them has the odd power, that means we have the option to choose which one to split, the cos to the power 5 theta or sine to the power 7 theta. That's up to us. You can work, or you can find the answer for both of the cases, even if you split up sine or you split up cos. It doesn't matter, you will get the answer. But there is a small suggestion from me is that if you have this kind of situation where both of them share the odd power, then take the smallest one. So in this case, we have 7 to the power 7, sine to the power 7 theta and cos to the power 5 theta. 5 is smaller than 7. So I will split cos here. But again, if you want to split sine and do the problem, definitely you can do, but that calculation will be longer than this calculation. Okay. All right. So what do you have? We have 0, and this is pi over 2. And then sine to the power 7 theta, we do nothing, sine to the power 7 theta. But cos to the power 5 theta, there we write cos to the power 4 theta and 1 cos theta with d theta. Now we do not change anything here, cos theta d theta, we keep it as it is, and we change the rest of the thing in sine. So that would be 0, that would be pi over 2, and this is sine to the power 7 theta, that's good. But cos to the power 4 theta, we don't like it, we need to convert it into sine. So how do we do this one? It is cos to the power 4 theta, so definitely it can be written as cos square theta, and then again square. So square is square twice. All right. So the next one is 0, and that is pi over 2, and that is sine to the power 7 theta. And cos square theta, that can be written as 1 minus sine square theta, the inside one. And there is still 1 square outside. So you have to write there. Okay. Now we are ready to use our u substitution. So u equal to sine theta. Then du equal to cos theta d theta. But this one is a little bit different because this is a definite integration. So that means we have to also think about the limit. So when theta equal to 0, we need to know what is u. So u equal to sine 0, which is 0. Then if theta equal to pi over 2, then u equal to sine pi over 2, which is 1. So we can now change our problem in the following way. This would be 0 to, instead of pi over 2, that would be 0 to 1. Sine to the power 7 theta will be u to the power 7. And this would be 1 minus u square, again square, and this whole thing would be du. All right, so we have to distribute, but before distributing we can see there is a square there, so that means we have to expand that one first. So that means this is u to the power 7 and 1 minus u square whole square, that can be written as a square minus 2ab plus b square formula. So 1 minus 2u square plus u to the power 4 d. All right, so this is 0 to 1, and let's multiply that out. So that would be u to the power 7, that would be 2 u to the power 9, and then finally u to the power 11 du. All right, so what do we need to do? We need to find the integration of this one, which is e to the power 8 over 8, then 2 e to the power 10 over 10 plus u to the power 12 over 12. And we have to plug the upper limit and the lower limit. Now let's plug the upper limit. If I plug the upper limit, that would be 1 over 8 minus that would be 2 over 10 minus that would be 1 over 12. Do not, I am saying again, do not use decimals. I have already graded your homework 1 and 2. You can see if you haven't already seen it. If you go e-learning, you can go through that graded homework and you can find out where I have. If you have done everything correctly, you are getting full credit. But if you have got less than full credit, that means you did something wrong. And what did you do something wrong? I pointed out there in the paper. So it's really a good practice to go through the graded homework so that you can find out what type of mistakes you have made and usually prone to make. Then next time you can change it. So one of the things that I have found while grading the homework, that some of you still, even though I have told you several times in my previous problem session, never ever use any decimals. But still I have found that on some cases you are using some decimals. Especially on the graded homework 1, you had a problem, the last problem, which was find the value of v minus w, then find the magnitude of v minus w, and then find the unit vector opposite to that v minus w. So which is negative v minus w divided by the magnitude of v minus w. Now the thing is that that magnitude was square root of 68, which is not a perfect square. So some of you have used a decimal value for that square root of 68, which is not at all acceptable. Okay, so most of the time it will be your last choice, or if you are told to use decimals or round off. Round off is always we would like to avoid. We don't accept it. So in this case, let's do this one. What do you need to find? You can use the calculator or something, but not in some calculator you can do that fraction and the answer will be also given in fraction. Take that fraction and write it. Do not write any decimal version. Okay? So I don't. Yes, thank you. Yes, that's a mistake. It's a plus. So now I don't have a calculator right now, so I will be doing a normal calculation, which is 480. So if you have 480, that would be 60 minus, this would be 48, so 96 plus this would be 40. So you can do this one in very simple calculation. That would be 4 over 100, 480, which is 1 over 180. That is a nice answer. Okay, fraction is very nice. We always like it. We always accept it. Decimal, not so much. All right. Do you have any questions? Thank you. So if you don't have any questions, let's move on to the next one, which is another definite integration. And in this case, now it started that there is no sine or cos who has odd power. It is even power. So if it is even power, then we have to take the help of another formula, which we call double angle formula. Okay, what is this? This is this. So if you have cos square x, then you should know that cos square x, if we want to get rid of the power, we can write this double angle formula, which is 1 plus cos 2x divided by 2. That's the cos square x formula. And the next one is also important. If you are thinking about sine square x, you can write 1 plus, that is 1 minus cos 2x divided by 2. If you don't remember, or if you haven't seen, if you feel like that you haven't seen the formula, don't worry, but for this course you need to know this formula very well. Okay, very well. You will use this one quite often. Now let me show you how to use that one. First, looking at the problem, we can see there is a 2 involved here, cos to the power 4 2t. So we want to get rid of that 2t first. Okay, that 2t first. How do we do this one? Let's do a simple u substitution. Instead of u, let's do it x. Let's write x equal to twice t. Then dx equal to 2 dt. Okay, and again we need to think about the limit. So if t is the t, so if t equal to 0, then x equal to 0 as well. if t equal to pi, then x equal to twice pi. Okay. So what do you get? We get 0, 0 to 0, and pi will be changed into 2 pi, and then this would be cos to the power 4, and again twice t will be changed into x, and dt is changed into dx over 2. So let's get rid of that 2 and write it at the beginning. So 1/2, then 0, this would be twice pi, and this is cos to the power 4x dx, right? And now it seems like we can calculate this one in our normal thinking. Since we don't have any 2 anymore, it's a normal simple cos to the power 4x dx. Now we can apply our IT. What is the idea? We need to replace this even power with our double angle formula. So that means this would be half, and this is 0 to twice pi. Cos to the power 4x, that can be written as cos square x and then square again. Okay, so that would be half, and this would be 0, this would be 2 pi, and cos square x can be written as 1 plus cos 2x divided by 2, and again square is still outside there. Okay, so we can distribute that square to both of them. So that means this would be 1/2 and this would be 0 to twice pi. Then the numerator will be a plus b whole square formula. So that means 1 plus 2ab, so that means 2 cos 2x, plus b squared, that means cos square 2x, and divided by denominator square, which is 2. So 2 square means 4, and dx. So that 4 I can take it out, so that would be 1 over 8, and this would be 0 and 2 pi. And in this case, if you look closely, I can see that 1 plus 2 cos 2x, so far we are good. We can find the integration. But again, looking at cos square 2x, we can see, okay, we have a power. And we know for sine and cos, if we have a power, we don't know how to find the integration. So again, we have to get rid of that power, and we know we can get rid of that square by using the double angle formula. So again, we have to use one more time. So that would be 1 plus cos. Now this time instead of 2x, that would be double of double. So that means it would be cos 4x divided by 2. Okay. So far still we are good. Now before finding the integration, we need to simplify a little bit. That would be 0. This would be twice pi. 1 plus 2 cos 2x. If I distribute that one, that would be 1/2, and again 1/2 cos 4x dx. So we can see that we can add that 1 and 1/2, so that would be 0 to twice pi. 1 and 1/2 will be 3 over 2, and then that would be 2 cos 2x, and then this would be half cos 4x dx. Okay, so now we are ready to find the integration. 3 over 2, integration of this one is x, plus this would be 2, integration of cos is sine 2x, so that would be sine 2x, and since there is a 2, we have to divide by that 2. Then again this is half, and integration of cos 4x is sine 4x, and again since we have a 4, we have to divide by that 4, and then plug the upper limit twice pi, plug the lower limit 0. Okay. Now for the first one, we have 1 over 8, and if we plug the value 3 over 2 instead of x, we can write that is 2 pi. Plus, now let me ask you the next one is that if I plug twice pi on the next one, which is sine 2 times 2 pi, which is sine 4 pi, What is the value of sine 4 pi? 0. Very good. So we don't need to add this one. Forget about that one. Now go to the third one. If I plug twice pi on the third term, I can see that is sine 4x. So that would be sine 8 pi. Again, what is the value of sine 8 pi? That is also 0. So you can see that we don't need to add any more times because all of them are 0. Now let's think about the lower limit. If I plug the lower limit, again, the first term is 0, the second term is 0, and the third term is also 0 as well. So we can see that basically we don't need to add anything extra there. We can stop here. That's the stop, right? All the rest of the terms are 0. Now if I cancel that 2 and 2 out, then finally we have the answer as 3 pi divided by 8. Do not use the decimal. Do not take your calculator and type that 3 times pi divided by 8 and write that decimal. It is not acceptable. You will be penalized, at least 1 point for this one. Okay, write it in fraction form. That is the most nice thing you can do. Okay, so let's move to the next one. Again, we have a problem. Problem means that we have both of them even power. We do not have any odd power. So the strategy that we started with, that the first problem strategy, that splitting up the odd one, we cannot use that one any longer in this case. But we have learned just now in the previous, the very previous problem, that if we have an even power, then we can get rid of that power by using the double angle formula. We will do that one here. Okay, so we know both of them, that sine square x has a double angle formula and cos square x has double angle formula as well. So that would be 0 and this would be pi over 2, and sine square x, that can be written as 1 minus cos 2x divided by 2. That's the first one. And then again, second one is 1 plus cos 2x divided by 2 dx. All right, so now the time is to simplify. So this would be 1 over 4 outside, and that would be 0, and this is pi over 2. And if I multiply that out, then we can see this is 1 minus cos square 2x dx. Okay, you can multiply that, and there will be 4 terms. Among those 4, the second and third terms will be cancelled. So I just didn't write that one. I just directly write what is left after the multiplication. Now again we can see that again we have a power square there. Since there is a square there at the even power, we have to use the double angle formula one more time. So that would be 1 over 4, 0 to pi over 2, 1 is there, that's okay. And cos square 2x, that can be written as 1 plus cos 4x, not 2x, 1 plus cos 4x divided by 2 and dx. Okay. So we have to simplify. So 0, pi over 2, 1, distribute the denominator, so that means 1 half, minus 1 half cos 4x. Now what do you do? Take this, this is 0, this is pi over 2, 1 minus half, that means 1 half, then minus 1 half cos 4x dx. Now what do I have? We have to find the integration right now. 1 over 4. So half, so that means half x minus half, and different integration of cos is sine 4x, We have to divide by 4 as well. 4. And then you plug the value pi over 2 and 0. Okay, so what do you get? We get 4. Let's plug the value. So that would be 1 over half, 1 half x equal to pi over 2. Now, if I plug the value pi over 2 on the next term, I can see that sine 4x becomes sine 2 pi. Now, sine 2 pi is again 0. We do not need to plug the value. Now, let's plug the lower limit. If I put the lower limit, then I can see the first one, half x, that is 0, as well as half sine 4x over 4, that is also 0. So, no new terms are being added. So, that would be the end. So, we can just simplify and write it. The top one is pi 1 1, which is pi. The denominator is 4 2 2, which is 16. All right, any questions? Perfect. So we will move to the next problem, and next problem, it's a little bit new one. So far we have been doing all the problems, sine and cos or sine, all these two. Now we will change our boat to a little bit new direction, which is let's solve integration where we have tan and secant. Now, if you have a tan and secant, then you have to think a little bit differently is this way, that for this one, you have to separate. If you have secant and tangent, then you take secant square out. That's the split up term for this one, if it is possible. But if it is not possible to split up that one, which is especially when you have odd or something like this, it's a different situation, then we will do a different thing. We will show you. I will show you that. So for now, we can see that yes, indeed, it is possible to take secant square out from the given term. So if we do this one, that would be the tangent one, do nothing, tangent 4x. The secant 6, that would be written as secant to the power 4x, and then let's write secant square x out with dx together. And the idea is almost similar now, is that we do nothing with the last two terms, but the rest of the thing has to be in tangent. So one is done, tangent, but there is a secant 4x. That is also another thing we have to convert into tangent. Luckily, we know there is a trig function involving secant square and tangent square. In case if you don't remember, let me write this here, is that secant square x minus tangent square x equal to 1. Okay. We will use that one. So we have 10 to the power 4x, and secant to the power 4x can be written as secant square x and then again square, right? Same idea. Now what's the next one that we have is 10 to the power 4x, and secant square x, that can be replaced by 1 plus 10 square x. So 1 plus 10 square x, and there is a square outside. And now we have secant square x and dx is at the end. Now we are ready for our u substitution. So that would be u equal to 10x. So in this case, our du will be secant square x dx. That's perfect. Secant square x dx. So let's plug the value 10. That would be u to the power 4. And that would be 1 plus u square, then square. And secant square x dx is du. So far good. We have to expand this square and then distribute that u to the power 4. Okay. Let's do this. Nice. Now multiply or distribute. 4, 6, 8. Find the integration. 5 over 5. 7 over 7. 9 over 9 plus c. But we can stop here because it's in u. So we have to change it. So that would be 10 to the power 5 over 5. That would be 2 10 to the power 7 over 7. Okay, and finally we have 10 to the power 9 over 9 plus c.
I have a question.
Yes.
Why did you choose to, when we have tan to the power of 4 and secant to the power of 6, why did you choose to divide up the secant that was the 6th power? I thought we said when it was in both even functions, usually split up the one that has a smaller exponent.
Thank you for the questions, and that's not right. I said that one about sine and cos, and if both of them has odd power, only then you think about the smallest one. But when we started with tan and secant, all the thinking, all the strategy that we have used in sine cos, it's completely different. The strategy for the tan and secant, it's a different strategy we have to follow.
So what would you recommend to do instead for tan and secant?
For the tan and secant, if the first one you have to try that, can I split up secant square out? If it is, the answer is yes, start doing that one. But if it is not possible, say for example, in this problem, instead of having 10 to the power 4 times secant to the power 6, if I had, say, 10 to the power 4x times secant x. Now from secant x, it is not possible to take out secant square, right? Then there is a different strategy that I will show you in the next, later in this problem session. But for now, when you have tangent and secant, if the first step will be, first strategy will be, can I take out secant square out of that secant you have? If the answer is yes, go with that one.
Thank you.
Welcome. All right, so let's see this one. Again, you look at this one, you have secant 6 theta and tangent to the power 6 theta d theta. We do not need to think what is the power. We just need to ask ourselves, can I take secant square out of this given term? And the answer is yes, because we have more than 2. So definitely if we take 2 out, we are allowed, right? So let's take secant square out this side. So we have 0, and we have pi over 4, and we will take secant square out. That means it will be secant to the power 4 theta, and that would be 10 to the power 6 theta, and that splitting secant square theta will be written with d theta together. Now we will not touch this last two thing, but we will change the rest of the term, everything in tangent. So let's do that. So that would be 0, and this is pi over 4, secant to the power 4, that can be written as secant square theta, and again square, tangent to the power 6 theta, do nothing, it will be exactly as it is, and then secant square theta d theta. Okay, so we have 0, this is pi over 4, and this secant square, that can be written as 1 plus 10 square theta, and there is a square outside as well, and this is 10 to the power 6 theta, and this is secant square theta d theta. And now we can see that except the last two terms, everything is in tangent. So we are ready to use our u substitution. So u equal to tan theta, then du equal to secant square theta d theta, and also we need to think about the limit. So theta equal to 0, then u equal to tan 0, which is again 0, and if theta equal to pi over 4, then u equal to tan pi over 4, which is 1. So now my problem is the following. So this is 0 to 1. Instead of pi over 4, that would be 1, and this would be 1 plus u square and then another square outside, and 10 to the power 6, that would be u to the power 6, and that secant square theta d theta, the whole thing will be du. Okay, we need to expand. So if I expand, that would be 1 plus 2u square, then u to the power 4, and this is u to the power 6 du. Okay, so what do you have? 0 to 1. Let's multiply that or distribute out. So that would be u6, 2u to the power 8, and u to the power 10. Okay, so if you find the integration, that would be u7 over 7. That would be 2u9 over 9. And that would be u11 over 11. And we need to plug the value 1 and plug the value 0. So if I put the upper limit, then I can see that we have 1 over 7, 2 over 9, and that would be 1 over 11. Now if you do this one, normal calculation and everything, then what do you see? You see this would be 693, right? And then if you divide, that would be 99, and that would be 154, and this is 63. If you add all them up, I think that is 316, and then 690, and that's the answer. Because you cannot divide this one anymore, even though the denominator is divisible by 3, but 316 is not divisible by 3. So we cannot make it any shorter, smaller. That's, again, do not use the decimal. That's the warning. Do not use the decimals. Any questions? All right, so let's move to the next one, and this one is that problem that we are thinking that, so before doing this one, before starting our strategy, first we have to get rid of that 5 that we have, that 10 cube 5x and secant 5x dx. So that 5 is not nice for our strategy, so we have to get rid of that first. So let's do that one. So how do we do this one? Let's use a different variable, which is y equal 5x, and then dy equal to 5 dx. So if you have this one, let's use that one. So we have 10 cube, instead of 5x we have y, and then secant 5x, instead of 5x we have y, and instead of dx we have dy over 5. So we can take that 5 out, so 1 over 5, and our integration would be 10 cube y, secant y, and dy. And now it's a simple, so no other values multiplied with y to bother us. So we are now ready. Now again, I told you that when you have an integration where it is in sine, tan and secant, we have to first ask ourselves, the first question is that, can I take secant square out? In this case, the answer is no. There is only 1 secant there. So if I want secant square, I cannot take out from this secant y. So if it is like that, then the second strategy is this, that can you take 1 secant and 1 tangent out? 1 secant and 1 tangent out, which is, the answer is true. Yes, we can do it. So that means I can write tan square y, and that 1 secant y and 1 tangent y is now together with dy. Okay, now this thing will be unchanged. We will not touch it, it will be as it is. The other thing, that tan square y, that has to be now changed into secant. Previously everything we have changed into tangent, but in this strategy we have to, everything has to be changed into secant square. So this is 1 over 5, that tan square y, that can be written as secant square y minus 1, and the rest of the thing we don't touch it. That is secant y, tangent y, and dy. Now let's plug u equal to, in this case not tan, it will be secant y, and then what is du? Du is secant y tan y dy. Now what do you see? 1 over 5 integration secant square, which is u square minus 1, and this whole thing is dy. Sorry, not dy, it's du. Now this is just a simple integration. So u square, that would be u cube over 3 minus u plus c. But we cannot stop here because this is in u. We cannot write our answer in u. We have to go back to our x. So let's first go back to our y. So 1 over 5, or we can write 1 over 15 u cube, that will be changed into secant cube y minus 1 over 5 u. Again, instead of u, it would be secant y plus c. But again, y is not acceptable because look at the problem, it is in x. So that value also needs to be replaced. So 1 over 15 secant cube, instead of y equal to 5x, and 1 over 5 secant y, instead of y you have to write 5x plus c. And now we are done. Now you might ask, or you might have seen in some cases, that on some case I told you that if you ask yourself that, can I take secant square out, and if the answer is yes, then go with the first strategy, and if the answer is no, then go with the second strategy. Now if you ask that, is it straightforward and fixed, can we change the strategy? The answer is yes. For some problems you can change the strategy, but I don't want to put or give you more strategy and make more confusing. So I just want to like keep everything straightforward so that you just go follow the guidelines and go do this. But again, if you try or want to experiment or want to see, okay, other strategy, if I switch the strategy, does it work or it doesn't work or whatever, if you want to do this one, you are welcome to do this one. Okay, so especially for the tangent one, for some problem the strategy can be interchanged, like the first strategy and the second strategy, you can interchange that one. But for that one you need to think a little bit extra and everything, and I don't want to burden you with those extra thinking. Since we already know how to solve it, why not stick with what we know so far? All right, so this is one different thing. So far we have all sine and cos, tan and secant, and everyone has a power 2, 3, 4, 5, something like this. But what if we have a sine cos, but none of them has any power? Instead, both of them has different argument. Like in this case, sine has argument 8x and cos has 5x, which is completely, both of them are completely different. If both of them are completely different, then how do you do this one? If they don't have any power, that's the given condition. No power, but the argument has some value there. Then you have to know this following formula. Again, I don't know whether you know or don't know, but just to remind you that if you have 2 sine A cos B, then the formula is sine A plus B plus sine A minus. If you have seen before, congratulations, good news. If you have seen but don't remember, don't worry. Again, we are here to remind you. In the book, you can, if you go in the book, in the exercise and everything, in the example, you will see that these formula are given there. So if you don't remember, just freshen up your memory. Okay, you need it. So far for these 7.2 chapters, we really need 8 formula. First, we need all the trig identity, sine square plus cos square, secant square minus tan square, cosec square minus cot square equal to 1, that trig identity. Then you need the double angle formula. There are 2 formula there. And we need the product of sine cos. In this case, you have 3 formula for there. Okay. If you have 2 sine A cos B, and then another one you have, if you have 2 cos A cos B, and then you have 2 sine A sine B, these 3 formula. Okay. Now in this case, we don't need the rest of the 2, but you need to know. You need to know these 3 formula. So make sure that you freshen up your memory there. All right, so let's use this one. So what do you have? We have the integration, and in this case, just think that this 8x is your A and this 5x is your B. And if you follow the formula, then what do you see? There is no 2, so let's take this 2. Let's take this 2 and divide by this whole thing. It's the same thing. So what do you have? The first one, sine A plus B. So that means in this case, that would be 8x plus 5x, which is 13x. Then plus sine A minus B, which is 8x minus 5x, so that would be 3x, and divided by that 2. This is dx. Now we can see that we can find the integration. The first one, what do you get? Sine 13x. The integration of sine 13x is negative cos 13x divided by 13, but there is a 2 there, so that would be 26. And then again minus integration of sine is negative cos 3x divided by that value 3, but there is a 2 already there, so this would be 3 times 2, 6, and plus c. And done. See, if as soon as you know the formula, you plug the formula, this problem is a very simple, silly problem. But this same problem can be a headache if you don't know the formula. If you don't know the formula, no matter how you try or anything, you won't be able to find the integration. The formula makes the problem very, very simple. You can just find it. So that's it. So that these are all the strategies that has been used in the chapter 7.2, and you really need to kind of understand this one based on what is given and what strategy to follow. The challenging part, I believe that for the chapter 7.2, the challenging part is to choose the right strategy for the right one. If you just completely go in a wrong strategy, starting doing a different one, you will start doing this one. At the beginning, you won't even realize that you are doing wrong. But after some calculation, you will realize that, okay, the problem should have been much more simpler by the time you are doing, and you realize that that is not getting shorter, instead that is getting more complicated or something. And this, when you are using some strategy, and after 2 or 3 steps, if the problem is not nicer, it not shorter or more simplified version, then that should be kind of hint to you that maybe you have chosen the wrong strategy. You should change it. Okay. So this type of thing can be mastered. You can be expert on this one if you do lots of problems. Don't do just 1 or 2 problems and you say that, okay, I'm expert. No, do several problems. Then this will kind of put in your head. It will be in your head all the time that when you see some type of pattern, what you use, it will be automatically given. Your brain will tell you that, okay, I remember seeing this kind of problem and you have used this one, so let's use that one. So that experience is really, really a key factor for doing well especially in integration. 7.3 is really, really important. It is more complicated, more lengthier, more time consuming than the chapter 7.2, and that's why most of the time the points for the problem from this chapter is usually 10 or higher. Only one integration is worth 10 or higher points, because there are lots of steps to follow, and for those different steps the grade point is distributed accordingly. That so it has lots of steps, that's why at the end it has lots of points to begin with. Okay, so if you have this one, there are 3 straightforward things. So this 3 straightforward thing is that if you are dealing with this idea a square minus x square, where a is some number, okay, any number, but x is fixed, that x square or the variable square, that one is fixed. So if you have a square minus x square in your integration, or if you have a square plus x square, or if you have x square minus a square, these are the 3 different scenarios you might encounter. If you have that situation, there are some straightforward strategy to follow. If you have a square minus x square, then x should be replaced, or trig substitution will be x equal to a sine theta. If you have a square plus x square or x square plus a square, which one is, both one is okay, then x should be replaced by a tan theta. And if you have x square minus a square, then x should be replaced with a secant theta. So you need this one. So let's follow that one. If we follow this in this problem, we can see that in the problem we have x square minus 1 in sides, right? X square minus 1. So if I think about x square minus 1, actually this is x square minus 1 square, right? So if I compare with these 3, we can see this one follows the third one. So that means we know what to follow, what to do. What is this? We need to use the trig substitution for that x, and that would be a secant theta. But in this case, a is 1. So 1 secant theta means just secant theta. Let's see, does it really work or not? Okay, so the next step is find dx, and the dx is secant theta, tan theta, d theta. All right, so let's plug all the value that we know so far. So the first one, we have x square minus 1. So the x square minus 1, that is secant square theta minus 1. And then in the denominator, we have x to the power 4. So x to the power 4 will be replaced with secant to the power 4 theta. Good. Now dx. For the dx, we can write secant theta, tan theta, d theta. At this stage, it might seem that the problem is getting more complicated or more lengthier, but trust me, it's not like that. It will make your life easier when you are done. So the top one, sec squared theta minus 1, we know this is trig substitution, trig identity, so this would be tan squared theta. And 1 second and secant to the power 4 theta, 1 second is cancelled, leaving secant cube theta and 1 tan theta outside still. And then finally, square root of tan squared theta is tan theta. That is outside the tan theta, so that would be tan squared theta divided by secant cube theta d theta. Now I think that this problem looks simpler. Even though maybe at this point we don't know how to solve it, but at least it has become a much more short. Now another strategy right now is that if you find yourself finding the integration of tan and secant, and if you find that your given term is not multiplied, instead they are divided form, like tan over secant or secant over tan, either of them is divided form, then the best strategy is to convert all the value in sine and cos. Change to sine and cos. So let's do that. So we have tan squared theta. We know tan squared theta can be written as sine squared theta divided by cos squared theta. And secant cube theta, because 1 over secant cube is cos cube theta. So this is cos cube theta. Now we can see there are cos squared theta getting cancelled. So we have sine squared theta and cos theta theta. Now you can realize, hopefully you realize that this whole thing that we started with some peculiar thing. This thing has now changed into 7.2 problem, right? The chapter 7.2 we just finished, right? So this is the whole idea, that all the time the problem that you have in 7.3, you use the trig substitution to make it look like a problem in 7.2, since we now can believe ourselves that we are an expert in 7.2, all the trig integration. So this thing is the goal. The steps are, you first use the trig sub to make this problem a trig problem, and then use whatever we learned in the chapter 7.2 here. That's the whole idea behind this. Not everything included. There is an extra thing there. I will show you at the end. That will come up at the end. Now let's solve it. We know that this one is, we need to take an odd power and take 1 out of there. But in this case, 1 is already there, right? That cos theta d theta is already there. So that means it is already ready to be u substituted, which is u equal to sine theta. That means du equal to cos theta d theta. And if I plug it here, then I can see this is u squared du. Very simple. So that means the answer is 1 over 3 u cube plus c. But we are not allowed to write our answer in u. We are not allowed to write our answer in theta as well. We have to write the answer in x. All right, let's go back one step. So that would be 1 over 3. U is sine theta, so this would be sine cube theta plus c. But what is sine theta? We need to find sine theta. Now we can see that we know secant theta, but we don't know sine theta. So how can we find that one? We can find by using triangle. If you haven't used it, or if you have seen but you are deciding that I am not gonna use it, there is no option. You need to use it, you need to learn it. So that is, this is theta, and this is the right angle. And hopefully you remember that this is called opposite, this is called hypotenuse, and this is called, what do you call, adjacent or base? I don't know which one you are familiar with. Adjacent. So let's write it short A. So these are the combination. So let's see, we have, looking at the starting, we have x equal to secant theta. So let's think about x equal to secant theta, or let's think about secant theta equal to x. Actually, x can be written as x over 1, right? That's okay. But let me ask you, can you tell me what is secant theta equals in terms of hypotenuse, adjacent, and opposite? What is secant theta equal? Hypotenuse by adjacent, right? So this would be hypotenuse by adjacent. So if we have this one, that means the A is this value and H is this value, right? So let's replace this H by X and replace this A by 1. Then we can easily find O, right? The opposite is square root of hypotenuse square minus adjacent square. So that means x squared minus 1 square, which is 1. Now our goal is to find sine theta, not secant theta. So let's find out now. Let's find out what is sine theta actually is. So sine theta equal to, again, in terms of hypotenuse and adjacent or opposite, sine theta is opposite by hypotenuse, right? Opposite by hypotenuse. So opposite is x square minus 1 and hypotenuse is x. Let's plug this value here. So we have 1 over 3, we have x square minus 1 divided by x whole cube plus c, and that's the answer. Any questions? All right, maybe let's do more problems, then we will be more comfortable with trig substitution as well as the triangle idea. That triangle idea will be always there, so you have to really know this, what's going on there. So let's do more problems, and I hope that it will be more easier to understand, right? All right, so for this one, especially for only this chapter 7.3, I encourage you to do this one, or I believe that when you are trying to find the definite integration, always try to find the indefinite integration first, and then at the end, when you are done, plug the limit at the end. Trust me, this will make your life much more simpler. It doesn't mean that that's the only way. You can really do a different way where you are using substitution as well as you are changing the limit and doing everything, but that limit becomes very complicated. So I would suggest that when, especially only for this chapter, if you are trying to find the definite integration, the step should be number 1, find the indefinite integration first, then plug the upper limit and lower limit, and done with the definite integration. What I'm trying to say is that do not carry out the calculation of the limit all the way through. Don't take it. Just for now, stop thinking about the limits. Just find the integration, and at the last line, we will just plug the value and be done. Okay, so if we follow that way, then again, our strategy in this case, we have x square minus 1, which looks like x square minus 1 square. Again, if you go in the previous page, we have suggested that if you have this kind of idea, then x should be replaced by a secant theta. In this case, a is 1, so that means x equal to secant theta will be again our choice. Okay, say, so this is dx, this would be secant theta, tan theta, d theta. So good. Let's plug this value. Dx will be replaced by secant theta, tan theta, d theta. And now we have secant square theta minus 1 to the power 3 over 2. Okay. Then we have secant theta, and tan theta, d theta. Secant square theta minus 10 is 1 is tan square theta. Then you have secant theta, then tan theta, and tan square theta, if you multiply with the power, 2 and 2 is getting cancelled, and 3 is left, so tan cube theta. So 1 tan theta is getting cancelled. Then we have secant theta divided by tan square theta. Now before moving forward, let me ask you, I have told you that when you see this kind of situation, there is a strategy to follow. Anyone remember? What did I say? Very good. Change everything into sine cos. So secant theta can be written as 1 over cos theta, and 1 over tan square theta can be written as cot square theta, and cot square theta is actually cos square theta divided by sine square theta. Okay, so again multiply with this one, so we have cos theta d theta on the top, and at the bottom we have sine square theta. So we can take u as sine theta. So that means du equal to cos theta d theta. So that means this problem actually is as simple as this, just du over e square. That's it. Very simple. So the integration of this one we definitely know, which is negative 1 over u plus c, right? That's the integration. But in this case, we are actually do not need to write this plus c, because why? Because this is a definite integration. We will use the limit later. So if you don't want to write c, only this particular case, it's okay. If you write c, that is also okay. Okay, so we have negative 1 over u, but we have to go back to our actual x. This u, this theta, nothing works. So let's see. So what do you have? We have negative 1. Instead of u, we have sine theta. So that means negative cosec theta. But again, we don't want cosec theta. We want x. So let's do. So our problem started with x equal to secant theta. And we know x equal to secant theta. If you draw this one, then if it is the theta, then secant theta means hypotenuse by adjacent. So that means this is x, this is 1, this is x square minus 1 square root. Now let me ask you, what is the value of cosec theta? What do you think? Using this triangle, what is the value of cosec theta? I think cosec theta, right? Cosec theta is hypotenuse by, right? Good. This one is right. Cosec theta is hypotenuse by opposite. So that means this would be x divided by square root of x squared minus 1. We know cosec theta. Let's go back. So that means this is negative x divided by x squared minus 1. But our goal is to find the definite integration. That means 2, 3 dx and x squared minus 1 to the power 3 over 2. So that means we have to use this x square root of x squared minus 1 and plug the limit 3 and 2. Okay, so if I plug the first one, then I get negative. This is 3 over. That would be square root of 3 square minus 1, which is 8. And this would be negative, negative, positive. If I plug 2, that would be 2 divided by square root of 2 square minus 1, which is 4 minus 1, which is 3. Now in this case, do not take any more hassle. You can stop here and that is acceptable, because you can see the denominator is completely two different square root. So it will be, we don't want you to make it one fraction. It is acceptable. You can stop here. But I repeat myself very often, again and again and again, just to fix it in your head. Do not use decimals. Okay? Do not use decimals. That's the most, that's the worst thing you can do. Yeah? Do not use decimals. Okay, so we have this one. So far, both of the previous problem we have done with the same trig substitution, which is secant theta. Let's see whether in this case it's the same or different. So if we look at this one, first one is 9 minus x squared. That can be written as 3 square minus x squared. That means we know that a square minus x squared means we have to use the sign substitution. So x equal to a sine theta, but a is in this case 3, not 9. Careful, a is 3, the square root of that one. So 3 sine theta would be the trig substitution. Then what is dx? Dx would be 3 cos theta d theta. So for good, let's see. Let's do this one. So we have x squared on the top. That will make this one as 9 sine squared theta. And in the denominator, we have 9 minus 9 sine squared theta. And then dx is 3 cos theta d theta. Now let's take this whole value 9 and 3 outside. So 3 times 9, that is 27. And in the numerator, we have sine squared theta and then cos theta. That's on the numerator. And on the denominator, if I take out that 9, then I can see it's 1 minus sine squared theta. So far it's still good. Now we have 27 square root integration. This is sine squared theta times cos theta divided by square root of 9 is 3, right? And square root of 1 minus sine square is cos square, and square root of cos square theta is cos. Okay. So the next one is, you can cancel that 27 with 3, that means this will be 9. And cos theta is cancelled. That means only sine square theta d theta. Hopefully this looks familiar, right? If you have even power of sine, then we know the strategy how to solve it. Can you give me any kind of hint? Which strategy we should use now? Double angle formula. Very, very good. So we have 9. Then the sine square theta is 1 minus cos 2 theta divided by 2. And this is d theta. Okay, so we can take that 2 out. So if I take that 2 out, that would be 9 over 2. Good. And we have 1 minus cos 2 theta d theta. Now we need to find the integration of this one, which is very simple. The first one is just theta, and the second one is sine 2 theta divided by 2 plus c. This is indefinite integration, so plus c must. Then we get 9 over 2 theta, then minus 9 over 4 sine 2 theta plus c. But we know by this time that theta is not an acceptable answer. We have to go back to our x. How to do this one? Let's do that. So we started with x equal to 3 sine theta. From this one, we can write that sine theta equal to x over 3. So we know that sine theta actually opposite by hypotenuse, right? That's the sign. So if I find a triangle where this is theta, then opposite would be x, hypotenuse would be 3. Then the base would be hypotenuse square, which is 9, minus base square, which is x. Now let's ask what we need. We need theta, we need sine 2 theta, right? So first let's find out the theta. Theta is very easy because sine theta equal to x over 3. So theta will be sine inverse x over 3. First one done. But what about sine 2 theta? Let's find out sine 2 theta. Sine 2 theta equal to 2 sine theta cos theta. Remember the double angle formula. There is a double angle formula for sine as well. So 2 sine theta cos theta. So now that 2, but what is sine theta? Is x over 3. So far good. But what is cos theta? Cos theta is adjacent by hypotenuse. So that means cos theta will be square root of 9 minus x square divided by hypotenuse, which is 3. And that is, so if I write it in here, what do I get? We get 9 over 2. Instead of theta, it is sine inverse x over 3 minus 9 over 4. Instead of sine 2 theta, we have 2 x over 3 and square root of 9 minus x square over 3 plus c. But do not stop here because you can see lots of things are getting cancelled. So let's do that one and make it more simpler. So that is 9 over 2 sine inverse x over 3 minus 2 and 4 is getting cancelled. This 3 and 9 is getting cancelled. So basically it's just half x square root 9 minus x square plus c. Typically, if you have this problem in the exam, the grade will be distributed like this. On the correct trig substitution, there will be some point here. He has this one. Then for the calculation, you have some point there. And for the triangle using this one and finding the correct value of the required terms that you have at the end, that is different points. And finally, reach to the correct answer, that is another point. So there are lots of places where the grades, the points will be distributed, and that's why typically this type of problem worth 10 or more. Okay, it is. Okay, so we have this one, and I told you that at least for my strategy, I use this idea, and I recommend you to do this one. That for this chapter 2.7.3, if you have a definite integration, for now you just find the indefinite integration first and then plug the value. Do not carry on your limit. If you carry on your limit, yes, definitely if you can do all the calculation right, you will end up with the right answer, but the calculation will be very complicated. Okay, so in this case, instead of the definite one, we would like to find the indefinite first, which is 4 minus 9x squared dx. The problem is that there is a 9 in front of x squared, and our trig substitution does not allow us to write any number in front of the x squared. Okay, if you have anything but 1, then you have to do something to get rid of that. Let's do that. So we do not like that 9. So let's take out the 9. If I take out the 9, then the first one would be 4 over 9 minus x squared dx. Let's take that 9 out. So that would be 3 square root of 4 over 9 minus x squared dx. It looks much simpler. So now we can use the sine theta trig substitution. So x will be a. What is a? Square root of 4 over 9, which is 2 over 3 sine theta dx. 2 over 3 cos theta d theta. Let's plot the value. So that would be 3. This is integration 4 over 9. X squared is also 4 over 9 sine squared theta. And then dx is 2 over 3 cos theta d theta. 3 and 3 is getting cancelled, 2 is out. And if I take 4 over 9 out, then it is 1 minus sine squared theta. And outside is cos theta d theta. Okay. So on that case, what can we do? We can take that 4 over 9 square root that out. That would be 2 over 3. So that is 2. And it is 2 over 3 square root 1 minus sine squared theta cos theta d theta. So we can see that this is 4 over 3, and 1 minus sine square is cos square. Square root of cos square is cos, but there is another cos at the end. So in total, we have cos squared theta d theta. Now, I don't want to ask you because you already know that one, because it's the similar situation of the previous problem. When you have sine square or cos square, the only way to go is to use the double angle formula. So let's use that one. 4 over 3 integration of 1 plus cos 2 theta divided by 2 d theta. That 2 is getting cancelled. That would be 2 over 3. And the integration of this one is theta. Integration of cos 2 theta is sine 2 theta. But there is a 2 again. Plus. So in this case, you can add plus c, but I'm not adding plus c because this is a definite integration. We don't need the c, because at the end we will replace everything with the upper limit and lower limit. Okay, so we have 2 over 3. Then we have 2 over 3 theta plus 2 and 2 is getting cancelled. That would be 1 over 3 sine 2 theta. So our question again, we need to find our value theta, we need to find our value sine 2 theta. And we started with what? X equal to 2 over 3 sine theta. We started with that one. So from that one, what do you know? Sine theta equal to 3x over 2. All right. So if I use the triangle now, then from the triangle, that sine theta means opposite. So opposite is 3x by hypotenuse, so which is 2. Now this base will be hypotenuse square, which is 4, minus the opposite square, which is 9x squared. Okay, so we are interested actually in sine 2 theta. We know sine 2 theta equal to 2 sine theta cos theta. So that would be 2. Sine theta is 3x over 2, and cos theta equal to adjacent by hypotenuse. So adjacent is 4 minus 9x squared divided by hypotenuse, which is 2. Okay. So if I use that one, what happens? 2 over 3. What is theta? Theta is sine inverse 3x over 2 plus 1 over 3. Sine 2 theta equal to 2 3x over 2 and square root of 4 minus 9x square divided by 2. Let's make it simpler. So that would be 2 over 3 sine inverse 3x over 2 plus 2, 2, 3, 3, all of them are cancelled. We have half x square root of 4 minus 9x square. But again, that's not the final answer because we are actually interested in the definite integration, which is this. We started from 0 to 2 over 3 and square root of 4 minus 9x square dx. So we have to plug the value upper limit and the lower limit. Before that, 2 over 3 sine inverse 3x over 2 half x square root of 4 minus 9x square and upper limit 2 over 3, lower limit 0. Let's plug the upper limit. So if I plug the upper limit 2 over 3, that would be sine inverse 1. If you plug 2 over 3, 2 and 3 cancel, so 1. Plus, if I plug 2 over 3 there, then this is 0. Let's plug the lower limit. If I plug lower limit there, sine inverse 0 is 0, so that is also 0. Again, if I plug 0 there, that is also 0. Okay, so everything is 0 except 2 over 3 sine inverse 1. But another thing we know that sine inverse 1 is actually pi over 2. So again, 2 and 2 is getting cancelled and finally giving us our answer as pi over 3. One of the smallest answer. To get it, we have to do one of the most work comparing to other problems, right? Nice, small, very tiny answer, but to get it, you can see that we had to go through a lot. Right? Lots of things. Any question? Okay, so if you don't have any questions, move to the next one. While writing the solution and everything, if you want to take a note and you want to go through the previous page and everything, you can ask me, I can wait. Unless I will just move on to the next one on normal pace. So far we have done both of the integration trig substitution. One is secant, one is sine. The last one we haven't used, which is the tangent one. Now we have that situation. In this case, we will use, because the plus. So in this case, we know that if we have a plus, then that x needs to be replaced by a tan theta. In this case, a is square root of 4, which is 2 tan theta. What is dx? Dx will be 2 secant square theta d theta. Let's plug those values. X cubed. So 2 tan theta cube will be 8 tan cube theta, and square root of 4 tan square theta plus 4. And instead of dx, it would be 2 secant square theta d theta. 8 and 2 out, so 16 out. And we have tan cube theta. And numerator, we can take 4 out. If we take 4 out, that would be tan square theta plus 1. And we have a square root sign there. And we have a secant square theta here and d theta. So far good. We have 16. We have tan cube theta secant square theta. And in the denominator, we have 2 square root of secant square theta will be secant theta d theta. So 2 and 16 will be 8. And we have what? 10 cube theta and secant theta d. Definitely this is a familiar problem. We have done this problem in section 7.2, and we know that if we have 10 and secant, then we have to ask ourselves, can we take secant square theta out? In this case the answer is no. So if the answer is no, then the second strategy, the next strategy is to take secant theta and 10 theta 1 out. So this case this would be 10 square theta, and I can write secant theta times 10 theta d theta at the end. And now we will use our substitution, u equal to secant theta. Then du equal to secant theta 10 theta d theta. Okay. Now, what do you have? We have 8. But 10 square theta, we have to replace it by secant square theta minus 1. And the rest is secant theta 10 theta d theta. Now let's plug the value. So that would be u square minus 1 du. So from that one you have 8, and this would be u cube over 3 minus u. Okay, u cube over 3 minus u. And what do you do? In this case we have, so this is a definite and indefinite. Indefinite. So when we are done, we have to add c. And now what do you have? I have 8 over 3 u cube. That u has to be replaced by secant, so that would be secant cube theta minus 8u. So that would be 8 secant theta plus c. Alright, so again, what do you know? That we don't really like that value secant theta. We have to replace it by the triangle idea. What we started with x equal to 2 tan theta, right? X equal to 2 tan theta. So from that one, we can write that tan theta equal to x over 2. So that means if this is theta, then this would be x and this would be 2, and this would be x squared plus 4. So from that one, if I ask you what is the value of secant theta, and secant theta is hypotenuse by adjacent. So that means this would be x squared plus 4 divided by 2. Let's use that one. Then we have 8 over 3, and this would be x squared plus 4 divided by 2 cube minus 8 square root of x squared plus 4 divided by 2 plus c. We can do a little bit more simplification, that 8 and 2 cube, that would be also 8, so this would be only 1/3, and this would be x squared plus 4 cube, and here 8 and 2 is getting cancelled, so that would be 4 x squared plus 4 plus c. And that would be the final answer for this problem. All right, so let's move to the next one. We need to find the integration of this one, but since we have, I think, just one more, we have time to do one more problem. So let's see this, and this one. I would think that let's do the last one. Last one is a little bit tricky one. Okay, if we can do the last one, then if we do the 8, number 7 is very close to that one, and number 6 is very close to the previous one, this one. So we can touch everything. So to do this one, what do you have? We have x squared, but there is another x there. So we have to make it perfect square first. Okay, when you have this kind of extra x, then to make this perfect square, what do I need to do? I need to do these things. That we know that this is x squared plus 2x. Somehow, if we can add 1, that will make this whole thing a perfect square, x plus 1 whole square. But the bad news is that 1 is not there. So since 1 is not there, but still we have written 1, we have to also subtract that 1 as well. So we are just adding and subtracting at the same time. Then what do you have? We have square root of x plus 1 whole square minus 1 dx. Okay? Now take this x plus 1. Think about this one as just x. This x plus 1, since this is x square minus a square idea, that means this one has to be a secant theta. So x plus 1 equal to secant theta. Okay, so what is dx? Our dx is secant theta tan theta d theta. Let's see whether it works or not. X plus 1 square, which is secant square theta minus 1, and dx is secant theta tan theta d theta. Now square root of square theta minus 1 is tan square theta. Square root of tan square theta is tan theta. So that is tan theta secant theta again tan theta d theta. Okay, so what do you have? We have in this case secant theta times tan square theta d theta. Now this is one of those problems where if you try to use the secant theta tan theta all the strategy, like can I take secant square theta out, or if it is answer is yes no, then if I write secant theta tan theta separately, and then can we do this one? The problem is in this case it would be very difficult to solve that way. So we have to use a little bit different idea there. What's the idea here? The idea is this, that you have secant theta, and the tan square theta can be written as secant square theta minus 1 d theta. From that one, what do you get? We get, if we multiply that out, that would be secant cube theta d theta, that's one integration, minus here that would be secant theta d theta. Now anyone remembers that what is the answer for the integration of secant theta? Yes, very good, very good. This is this one we already know. So the problem is not there. This one is, since we already know this one, our goal is now let's find it separately. Let me show you how to find the secant cube theta. Okay, so if we want to find the secant cube theta d theta, the idea is that first you multiply secant theta and secant square theta d theta, and on that case, what do I need to do? We need to do the integration by parts idea. where u will be secant theta, and dv would be secant square theta d theta. Let's find out du. That would be secant theta tan theta d theta, and in this case v, integration of secant square theta is tan theta. Hopefully you remember this one. Now what's the formula? Formula is u times v, so that means this is secant theta times tan theta minus v du. What is v? V is tan theta, and what is du? Secant theta tan theta, right? Secant theta tan theta d theta. Okay, now at this point, sorry, it is tan theta v du, so secant theta, another tan theta there. So what do you have? We have secant theta tan theta, so far good, minus this one is secant theta tan square theta. If you look what we have been trying, you can see that this is the same problem came back, right? The same problem came back. So if the same problem came back, we know one way. I have done one simple problem like that one, which was a little bit. So what was that? So let's do this one. That definitely these two things are equal, right? Because they are equal. So definitely I can write this, that secant theta times tan square theta d theta equals the integration of secant cube theta d theta minus the integration of secant theta d theta. But for now, what do I have? The secant cube theta, we have solved it. That is secant theta tan theta minus secant theta tan square theta d theta. And the last one we already know, that is natural log of secant theta plus tan theta. But what do? We take this one on the other side. So if I take this one on the other side, then it becomes 2 secant theta tan square theta d theta equal to secant theta tan theta minus ln secant theta plus tan theta. So from that one, our integration, that was this whole pain we had to go through, that whole thing is half secant theta tan theta minus half ln secant theta plus tan theta. Still we are not done. That's the bad news. Why? Because we have to go back to our x. Yes, okay. So secant theta we already know. So we just need what is tan theta actually. So if we know the tan theta, then we easily can find it. So if it is the theta, then secant theta, that means this would be, secant theta means hypotenuse by adjacent. So that means this is x plus 1. This is just 1. So that means this would be x squared plus 2x. So from that one, what would be our tan theta? Tan theta is opposite by hypotenuse, so x squared, opposite by base, adjacent. So x squared plus 2x will be our tan theta. So let's plug it here. I have not enough space here. I'll just put it right there. It is half. Secant theta is x plus 1. Tan theta is square root of square plus 2x minus half ln secant theta is x plus 1 plus tan theta is x squared plus 2x. Wow, that was a long one. All right, and that ends our problem session today. Do you have any questions? Then you can ask, or otherwise, thank you very much for attending the problem session. And if we have any questions, maybe outside of this problem session, you can just email me. We can discuss about what problem